Hello all of you and welcome to second session of motion chapter. In this session we are going to be discussing about displacement and distance in detail. That what do we mean by distance and what do we mean by displacement. So let's see what do we mean by distance and displacement. In the previous video, we discussed about motion and rest in detail, as well as we talked about uniform motion and non-uniform motion. I talked about reference point also. If you haven't watched that video, please go and watch because that is very, very important. And in this video, we'll be talking about two important things that are distance and displacement. And it is going to be super duper important because these two topics are very scoring and they come off many marks in the exam. Okay, so just remember and we'll do step by step all the concepts we are going to clear. So first let's see what do we mean by distance. Basically distance is the total path covered by an object. What will I say? That distance is the total path. So distance is the total path covered by an object, by any object. Okay. Now coming to displacement. Then what is displacement? What do you all think? What can be the displacement? Let's answer this question. Now let's see what is displacement. So displacement is the shortest path covered by an object or shortest distance between final and initial position. That means suppose this is the final position, this is the initial position. So it is the shortest path, right? So distance is the total path, like here to here, then here. So this all is going to be the distance, whereas displacement is going to be the shortest path between final and initial position. I hope now distance and displacement is clear. We are going to see some examples to understand distance as well as displacement because through those examples, it will be more clear to us. Now we are taking some examples. Let's see example number 1. In these examples, we need to identify that what is the distance and what is the displacement. So let's see example number 1. We can see this. This is A point. Then this is B, C, and D. Okay. This is 10 meter, 10 meter, and 10 meter. Now, what do you think will be the distance and the displacement in this case? What do you all think? See, distance is the total path. So 10, 10, 10. So I can say that distance is going to be 10 plus 10 plus 10. That is nothing but 30 meter. So your distance is nothing but 30 meter. What about displacement? Displacement is the shortest path. This is our initial position A. Final position D. How much? 10, 10, 10. Again, it is 30 meter. So with this, we can say that here distance and displacement are equal. And one more fact I would like to tell you that displacement is either lesser or equal to the distance. Okay. So I would say that displacement is lesser or equal to distance. Always keep in mind. And displacement is always equal to distance in the straight line motion. Otherwise, always displacement is lesser. Because in the straight line, we can see that distance and displacement are going to be equal. And in many a times, like if we talk about the circular motion, their displacement is 0. Remember this, because now we are going to do other examples also for clarity. Now let's move to the example number 2. Let's see what do we have in example number 2. So we have this. Let me use a line. Yes. And now it is somewhat like this. This is the figure. Now I can say that this portion is 10 meter. This portion is 10 meter. This is A part. This is B. And this is C. Now in this figure, we need to tell that what is the distance and what is the displacement. So how will we identify in this figure? What do you think? See, distance, we know distance is the total path. A to B, B to C. 10 plus 10, very easy. That is nothing but 20 meters. So displacement is, distance is 20 meter. What about the displacement? Now in displacement cases, always mark the initial and final position. So 1 minute. Yes, this is the initial position. This is C point is the final position. So I can say that this line, this is the displacement, isn't it? This is only the displacement. Then how will we identify this? How are we going to write it? See, if you can see, this is forming a right angle triangle, and this AC is the hypotenuse. So using Pythagoras theorem, we can easily find out. So let's find now using Pythagoras theorem. This is Pythagoras theorem, okay? So in Pythagoras theorem, I know, 1 minute. Let me erase this part. In Pythagoras theorem, I know that AC square is equals to AB square plus BC square. That means that here AC square will be equals to 10 square plus 10 square, because we know the measurement of AB, that is 10 meter, BC, that is 10 meter. So this AC, for finding the displacement, we are going to use the Pythagoras theorem. That is equals to 100 plus 100, that is equals to 200 meter. 1 minute. Yes. So then AC will be equals to under root of 200, because AC square is 200. So if we shift that square that side, so it will become under root here. So AC will become, so if we just factorize 200, what are we going to get? So how much is it going to be? 2 into 2 into 2 into 5 into 5. Now you know normal mathematics. AC is going to be, so we have this 2, 2, a pair of 2, a pair of 5. So 2 into 5, 10, and 1, 2 is left, 10 root 2 meter, which is equals to displacement. Easy. This is 10 root 2 meter. And this is the displacement, and the distance is 20 meter. So example 2 also we have solved. Now let's move to the next example. Yes, this is our example 3. Let's identify the distance and displacement in this case. So we know the formula of distance, that is total distance. So here distance is going to be very, very easy. It is going to be 10 plus 10 plus 10. That is nothing but 30 meter. This is your distance. Right? Because the total path, A to B, B to C, C to D. And the displacement is this red line, that is AD. So how do we do this? It is very obvious. We know that all the three sides are equal. So this should be 10 meter. So in this manner, we have completed this question as well. Now let's move to the next example. Acha. So in this case, what will be the distance and displacement? So distance is going to be 40 meter. Yes, if we are 10, 10, 10, the distance is going to be 40 meter. And if we see the final and initial position is the same, that means displacement is 0. You should know the cases in which displacement is 0 and in the cases in which displacement is equal to the distance. So those cases are very, very important because those cases can even come in the exam. Like in the circle, distance and displacement is 0 in a circle. Always remember. And distance is whatever is the circumference you can find by the formula 2 pi r if it comes in the examination, 2 pi r. Okay, and if you are talking about semicircle, then pi r, very simple, 2 pi r upon 2, so pi r. If it comes in a semicircle and you have to find the distance and displacement, so you can find through pi r. Now I've told you all the important things about distance and displacement. Now let's have the differentiation between distance and displacement. Yes. So first thing about, let's have distance and here I have displacement. I'm writing S only. Fine. So first thing about distance is the total path. This is the total path. This is the shortest path. You can learn by S and shortest. Then second point I can say that distance is scalar quantity, whereas displacement is a vector quantity, meaning that in distance we do not have to mention the direction, whereas in displacement we have to mention the direction. The displacement depends upon the direction of the object as well. Okay, as well as magnitude, and distance does not depend upon the direction. This is a major difference, and its distance can never be 0. Okay, distance can never be equals to 0, because if somebody is changing its direction and taking some path, how can it be 0? It will at least take 1 meter of distance. Displacement can be 0. Okay, as we have seen in the example where the initial and final position are the same. Okay, and distance is always positive. Displacement can be positive or negative. Okay, distance is always positive. These are the major difference part that you have to understand, and we are going to do some numericals on displacement in our upcoming classes, as well as we'll do speed and velocity. So thank you for today. I hope you enjoyed. Bye.